Robert Solis, welcome to this video lesson. I want to show you how we can use DeMorgan's rule to take this circuit and minimize it. And believe it or not, this whole thing is going to be reduced to just simply A. So let's take a look at what's going on. First of all, I have an inverter, so A goes into here, turns into A naught, B goes into this OR gate, and so therefore we have A naught or B. I have an AND gate over here with both signals A and B going into here, so that's simply going to be A and B. I have this exclusive NOR, so what will happen is, forget the NOR parts, which is just simply this line over here. It'll be the first input, which is A naught or B, that's the first part, and that's going to be exclusive ORed with AB, which is this part over here, and then we take care of this NOT right here, or this donut, and that's this line at the very top. All right, so let me go ahead and just rewrite that and put that over here. With the exclusive OR, we just do this. We say this and with this knotted, or with this knotted anded with this, and that's what you have over here. And then of course we have the overall knot on the very top. So it's this part over here. There it is, anded with this part knotted, or this part knotted, which you have over here, anded with this part not knotted. And then of course we have the line at the very top here. All right, well, if I do this little part right over here, that's going to be A naught and B naught. If I use the DeMorgan's law to change that, well, as you can see here, that's going to be A, that's going to be A, B, and B naught. Well, the B and the B naught pretty much zero that out, so this is going to be zeroed. In terms of this over here, that's the same thing as A naught, and I turn that to an OR, and then B naught. So I'm using DeMorgan's law to expand that. Well, then I'm just going to go ahead and use the FOIL method to say A naught and A naught. Actually, let's see here. I'm just rewriting it over here. Here we go. After I rewrite it, and then I use the FOIL method. So A naught and A naught. Right here, A naught and B naught. A naught and B. There it is. And then finally B and B naught. Well, the B and B naught, that just goes to 0. So we're left with this. And again, don't forget the overall naught operation at the very top. And A naught and A naught, that's just simply A naught. And then I'm rewriting everything else. Well, it looks like I can factor out A naught from everything. So if I factor out A naught, that's going to be 1, B naught, B. So I have this 1 or anything is 1. So in essence, I have this A naught and then the naught on the very top, which the naught of A naught is A. So in other words, when the signal A is on, then the output is on. Any other time, the output is off. So I have a truth table over here to verify everything. And so you'll see that the output is in fact the same thing as A if you actually were to go through this. But I have a little circuit that I created just to test this. So let's see here. Anytime A is on, the output should be on. So let's see here. Let's try having B on. Nope, nothing. B off, nothing. How about when A is on? Okay, so certainly the LED lights up, and this is off. How about when B is on? Yep, it's still on because, once again, as long as A is on, then we're going to get the LED to light up. And that is it. All right, so this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.